Now let us solve another problem. A student rides on a bicycle at 8 km per hour and reaches his school 2.5 minutes late. The next day he increases his speed by 2 km per hour and reaches his school 5 minutes early. How far is the school from his house? Okay, so here also there are two cases. One is case 1 and the other is case 2. Okay, so in case 1 he is going with a velocity of 8 km per hour, and in the case 2, how about the velocity? The next day he increases his speed by 2 km per hour. So increased by, in the sense you have to add whatever is the increased amount. Okay, 8 km per hour plus 2 km per hour. Okay, so 8 plus 2, that is 10 km per hour. Okay, so if he travels at this speed 8 km per hour, he reaches his school 2.5 minutes late. Okay, and in the case 2 he is reaching 5 minutes early. Okay, so here it is late and here it is early, both are there. So in order to find the delta t, what you need to do, if one is late and one is early, you just have to add them, that is 7.5 minutes. Okay, so ultimately what you need to find, the distance between the school and the house. Okay, for that we have a ready-made formula, that shortcut method. In order to find the distance, the formula is delta t into v1 into v2 by v1 minus v2. Okay, so now delta t is how much? 7.5 minutes, and you have to convert this into hours divided by 60. Okay, that will write in the denominator into what is v1? One is 8, one is 10, and 7.5 divided by 60, right? This. And what is the v1 minus v2? The difference, one is 10, one is 8. 10 minus 8, that is 2, right? Okay, so this is the thing. And now after cancellation, okay, so it is 5 kilometers. Okay, so this is how very easily you can solve this by using whatever the shortcut method that we have. Okay, using this simple formula. Now let us solve another problem. So here, if a car runs at 40 km per hour, it reaches late by 11 minutes. Okay, so that will be our case 1. So in case 1, so it is traveling with a speed of 40 km per hour and it is late by 11 minutes. And in case 2, so what is the traveling speed? That is 50 km per hour, and here it is being late by 5 minutes. So here, in case 1 and case 2 both are late. Okay, if in case 1 and case 2 both are same, I mean here both are late, like that even if both are early, we have only one rule, that is we just have to take the subtraction of this. We have to find the difference of these two. Okay, the times. Okay, so here it is 11 minutes, it is 5 minutes, right? So the difference will be 6 minutes. Okay, so the delta t value is 6 minutes. Okay, so we have a formula for distance, that is delta t into v1 into v2 by v1 minus v2. So delta t is 6 minutes, which is to be written in hours, right? So 6 by 60. Okay, 6 into this will be v1 v2, that is one is 40, one is 50. Okay, and 6 by 60, right? 60 into the difference of velocities, one is 50, one is 40, that is 10. Okay, so now, so this will be 20 kilometers. Okay, so the distance between the origin and destinations is 20 kilometers. So if you observe, they haven't asked to find out the distance. Okay, they are asking to find the correct time for the car to complete the journey. Okay, so in first case it is late by 11 minutes, and in the second case it is late by 5 minutes. Okay, they are not at all asking to find out the distance between the 2 points, but what is the correct time to reach your destination. Okay, so how to find this? Okay, you know the distance, okay, and you know the respective velocities in case 1 and case 2, and at that velocity at what time you have reached, whether you have reached early or late. Okay, we have these data only, but with this we have to find what is the exact time does it takes to reach 20 kilometers distance. Okay, so for that, it is easy. So if you take the distance, you can take any velocity. Okay, suppose if in case 1, if I take so this is the distance, right? So for case 1 the distance is how much? 20 kilometers, and the velocity is 40 kilometer per hour, right? So if you know the distance and velocity, can't you calculate the time? So time is equals to d by v, right? So here it is 20, v is 40, right? So this will be half, that is nothing but half an hour. Okay, so that is 30 minutes. Okay, if you take 30 minutes to reach a place, it is 11 minutes late. Okay, so from one place to another place, if you take 30 minutes to reach, you are late by 11 minutes. Then what will be the correct time to reach there? Okay, so you have reached 30 minutes, you have reached the place in 30 minutes, and it is late by 11 minutes. What will be the correct time? That will be 30 minus 11, that is 19 minutes. Okay, so similarly you can solve the same using the second case also. Okay, so here it is, so the distance remains same, that is 20, and the velocity is 50 here. Okay, so and this will be your time, right? So 2/5 of an hour. Okay, so into 60, so whatever you get here, that will be in minutes. Okay, so that will be 24 minutes. Okay, so if you reach a place in 24 minutes, that will be late by 5 minutes. Then what will be the correct time? 24 minus 5. Okay, that will be 19 minutes. Okay, so in the both the cases we have got the same answer. Okay, this is how you have to solve this. There is no direct formula to calculate that, but if you can calculate the distance, then you can easily find out the time to reach the destination by using any case. Okay, so this is how you have to solve this. Okay, so the answer is 19 minutes.